So my name is Liehr, and I'm working for the VDMA in Frankfurt in Germany. I'm very excited to be able to speak here today. So thank you very much for the invitation. And I'm going to talk about the OPC UA for machinery specification, especially about the new building block job management that is in the state of the release candidate at the moment. My colleague who is in charge of this specification, he was not able to come to this event today because of another event in Frankfurt, and that's why I am here. But I should be able to tell you anything, answer you all the questions, because I'm editor of companion specifications at the VDMA, and so I also know a few things about it. So let me begin. But first of all, I will let you know what the VDMA actually is. So the VDMA stands for the Machinery and Equipment Manufacturers Association for the engineering industry. And we have more than 3,600 member companies in our association at the moment. We are mainly structured in different trade associations, in regional and foreign subsidiaries, and in departments. And overall, you can say that the VDMA is providing or representing the interests of the OEMs that provide the devices for sites like construction sites or mining sites, factories for discrete manufacturing, and plants for continuous manufacturing. In the context of OPC UA and the standardization of information models, I want to highlight again the 36 trade associations we have. So as all of you know, the sector of the engineering industry is very broad. So there are a lot of different sectors in it. And because of that, we have one trade association for each important sector of our industry. So for example, we have a trade association for the glass industry, for machine tools, surface technology, robotics, and so on. So there are a lot of different trade associations that are specialized for their sectors. And a lot of these different trade associations are developing their own companion specifications, their own domain-specific information models for their sectors. So yeah, as you can imagine, there is a lot of OPC UA activity ongoing in the VDMA. And what I'm talking about today is the harmonizing approach that we want to do at this point with our specification and machinery. The VDMA is, as already mentioned, a globally active association. So our headquarters located in Frankfurt in Germany, but we have offices all around the globe. So for example, we have offices in Austria, Italy, or Poland for some European examples, but also in USA, in Brazil, in India, or China, for example. So together with the OPC Foundation, we are very happy that we are able to promote our specification work that is ongoing inside of the joint working groups on international trade fairs, international roadshows, or events like this. I think that's enough of the introduction. Now I want to start with the OPC UA for machinery specification. So I've just shown you that there are various sectors within the trade associations of the VDMA who are working on standardized information models for several years now. And if you follow different working groups from different sectors, then you notice that the use cases can be completely different. There are a lot of different parameters, a lot of different variables that are important for the specific industries. But in the end, almost every domain-specific information model and companion specification has some higher-level parameters, higher-level data that are relevant for all of the machines. And for this reason, we at the VDMA have decided to develop a basic specification for the whole machinery and equipment industry, and that's the so-called OPC UA for machinery specification. This specification is our harmonizing approach regarding a common cross-domain companion specification that is compliant with existing companion specifications and what also can be the base for all of the upcoming companion specifications out there. The machinery uses the concept of the so-called basic building blocks, and each building block stands for a specific use case at this point. And here it's important to mention that there are two different ways how to implement and how to use the OPC UA for machinery. One way is to integrate single building blocks into your vendor-specific information model or into your companion specification. Another way is to use the OPC UA for machinery specification as a standalone companion specification. For example, for special machinery who don't have a standardized information model or anything like this. So overall, we think that we are providing a very important aspect for the cross-domain interoperability with this specification. And yeah, I would say we have a look into the building blocks. So what is contained in the OPC UA for machinery? In the beginning, we started with the machine and component identification that is mostly derived from the device's base specification. But in this context, we are also enabling the use case for finding all of the machines and all of the components that are integrated to a server easily. And this is being done by integrating a so-called machines folder object, which can be directly integrated into the server object. And yeah, in this object, in this folder structure, you can implement your machine, and then it's easier to find all of the machines that are implemented. And the same is for sure working for the components, but the components are structured underneath the specific machines for sure. The second building block of the machinery specification is the machinery state. It contains two state machines, the machinery item state and the machinery operation mode. So the machinery item state machine or machinery item state machine provides information about the machinery item, and the states are not available, out of service, not executing, and executing. So as you notice, it's very basic state machine, but if you want to use this state machine in your companion specification or in your vendor-specific information model, then you can extend single states. A good example at this point is the companion specification for extrusion from the plastic and rubber industry. They extended the state of executing with some substates. Yeah, the machinery operation mode state machine provides the states non, maintenance, setup, and processing. And also here you can extend the single states with some substates. In general, an important use case for state machines are to getting some data like key performance indicators. And to give an example how you can use these machinery state machines to get your KPIs out of your machine or out of your process, we added an example to the Annex C of this machinery document. And in there, it is explained how you can combine these state machines and information from the upper-lying system to get your KPIs according to the ISO 22400 standard. So it's not another way to get KPIs, it's the officially standard 22400 from the ISO. Okay, the next building block, the counters, are pretty easy to explain. So if you want to count the hours your machine is working or it is turned on, or if you want to count how many days your license for any program or anything like this is still valid. So anything you want to count, you can use the machinery counters for. Another building block is the result transfer. Result transfer ensures the uniform receive of complex measurement results important for industries like, for example, machine vision or geometrical measurement systems, because they are, they have a lot of data in their processes. And this is being done by providing the metadata together with the individual results. The last building block that is released yet is the building block for process values. And process values contains a mechanism to ensure the harmonized representation of process values. So the great advantage here is that whenever you want to access some metadata of a process value, for example, engineering unit of this process value, a higher limit, a lower limit, or even a set point, then you can do it on a standardized way with this building block. To give you an example, if you want to monitor temperature value of a machine tool, you do it then on the same way, you get the metadata on the same way, like, for example, a flow rate in a shot blasting machine. So if you use the process values. The process value type in this case is an extension of the analog signal type of the PRDIM specification from the process industry. The upcoming energy management building block is going to be based on the ongoing joint working group for energy consumption management. And I think the previous presentation was pretty good about this topic. But now let's get to the main point of my presentation. I want to talk about the newest building block that is in the phase of a release candidate now, and it's called the job management. In general, the idea of job management can be drawn with two stakeholders and their lifelines. So on the left side, you see an upper-lying system, like, for example, an MES system. And on the right side, you can see a machinery item. The first step always is to transfer a job order from the MES system to the machinery item. In this case, a job order is a request for a unit of work to be executed, and it contains information and parameters the machinery item needs to actually execute the job. And once the job is done, the machinery item is sending back the results as a report of the work that has been done to the upper-lying system. This job result contains additional information that are related to this job then. So, for example, a bill of material or something like this. And it's comparable with the job order. It's just the other way around. So, in the end, the upper-lying system should have the possibility to clear all of the stored data that are still on the machine from the machine. And this is the whole idea of a job management that is common and that we had in mind when we started to developing this specification. Use cases we were defining here is to be able to start a job and bring all the data to the machinery item for sure. And it's also very important to be able to control the job. So you need the possibility to start it, to pause it, to interrupt it, and everything like this. Other use cases here are getting status information out of the current status, out of the machine. After finishing the job, we want to know, is it successful, and everything like this. And the last use case we defined here was the ability to clean all the job-related data from the machine. As I said, the machine is not meant to be a database. That's why. To developing a job management building block was not the idea of the machinery working group. So there were other working groups, like, for example, a working group from the flat glass industry, injection molding machines, machine tools, who already worked on something like this. And we noticed that and wanted to harmonize it. But the most important group that already worked on job management was the ISA 95 group for job control, based on the IEC 62264. And yeah, for us it was very important to take into consideration this specification and have a deeper look at it. And that's why we founded the collaboration working group together with the ISA 95 experts at this point. So in the end, our main goal was to define a common model for the job management that is extensible and modular. And at the same time, we wanted to care not to reinvent the wheel, but use work that has been done in other working groups. Our approach at this point of solving this was to split the process in two pieces, so defining the what and the how. So defining which information should be exchanged between these two parties and how should this information be exchanged. Let me start with the what. So the information that we send from the upper-lying system to the machinery item are needed. Then the information about the job status are needed. And finally, the data that we get back from the machine to the upper-lying system. The mechanism that describes how to exchange these data between the two parties has already been modeled in the ISA 95 specification for job control. And after evaluating this specification together with the experts from the ISA 95 group, we decided to use this transferring information model for our machinery job management building block at this point. So now I talked about how we got on this road and what we did until then. And I show you how this looks like now. So at first I want to show you the status, how the status of the machine can look like. And I show you this with the job state machine that is in the ISA 95 job control specification. So this machine, we are using this machine. So as you can see on the left side, we have the possibility to store or store and start a job. And depending on which method we use here, the status of the job is not allowed to start or allowed to start. If a job is in the state of allowed to start, the machine may automatically start this job, for sure depending on the resources the machine has and depending on the priority of the job. So if you push 5 jobs into the machine, then for sure the job with the highest priority will start. When the job starts to be executed, its status is switching to the running state. And at this point, the client also has the possibilities with some methods that you can see to pause the job, to interrupt the job, or to resume it afterwards. So after the job has been executed completely, the status is changing to ended. And at this point, the client has the possibility to clear all the job-related data from the machine again. So this is just a very quick overview over this state machine. So as you see, I would say it's one of the more complex state machines out there with a lot of methods, a lot of state transitions, and a lot of substates. So if you really want to get to know how the state machine works, I recommend you to have a look into the ISA 95 specification for job control. And if you got any open questions then for sure you can contact me or my colleagues and we will solve these problems. Okay, now after having a look into the job state machine, let's dig a bit deeper into the information model. And what we can see here is the job management type that provides the two objects job order control. Job order control derives from the job order receiver object type. And we have the job order result that derives from the job response provider object type. Let's have a look into the job order receiver object type at first. So this object type is necessary to receive and control the job orders. So on the left side of this type, you can see all the methods that are there to control the job. And some of them you can remember from the previous slide from the state machine. So we have store, store and start, update, and so on. So a lot of possibilities here. And a very important variable you can see on the right side, and this is called the job order list. The job order list is an array of jobs that have been received by the machine. And very important here is the order of the execution of the jobs that are in this job order list. So the array shall start with all executed job orders in the order the execution started, followed by all job orders currently executed or interrupted, also here in the order of the execution started, followed by the job orders that can start to be executed, followed by the job orders that currently cannot start to be executed. So, yeah, and the order of the jobs that can start to be executed, they shall be ordered based on the starting time and the priority. So as you noticed, it's well structured, and it's important to follow these rules when implementing. So take care to have a look into the specification again. Let's have a short look at the job response provider object type. Basically in here we find the response on the execution of the job order. So we have a method to pull the results out of the machine, and also here we have an array that contains the job order results at this point. So yeah, that's the information model of the job management building block, and this is how the integration into a machine looks like, or could look like. As an example, we have a fictional machine here, and underneath this fictional machine we have the machinery building blocks folder. Whenever you integrate some building blocks from the machinery, then it's important to implement this constellation, so to implement the machinery building blocks folder, because in the end, when an upper laying system, for example, wants to browse your server and it wants to know which machinery building blocks are integrated, then it will look for the machinery building blocks folder, but just for your information. Inside this folder we have the job management type and two more fictional building blocks that are not relevant at this point. And yeah, they are integrated as add-ins. The job management type contains, the job management type contains the job order control and the job order result. And now I want to show you what content you can put into a job order. So here we have a list of parameters that can be filled in the job order. The upper parameters are mostly for the identification of a job. Yeah, but there are also some other parameters, like for example runs planned, that indicates the number of runs that should be performed by the target machinery item. And yeah, there are many more parameters at this point. And we also have a parameter list for the job response. Also here we have the output parameters that are defined on top. So you can see the green parameters are the same for both because they usually don't change. And underneath there we have some other parameters, like for example runs completed, what is a counter that is counting every completed run, and yeah, actual produced quantity, and so on. So a lot of parameters at this point. As you can see, there are a lot of possibilities, maybe too much possibilities for some, And that's why we made all of these parameters optional at this point. So if you're interested in some of these parameters, but most of them are not interesting for you, you can just use this building block and integrate 10–15% of these parameters, and it's fine. That's better. Okay. Okay. Yeah, I think the time is not that much time left. But as a conclusion, I can say that yeah, the building block job management is currently in the phase of a release candidate, and we are reviewing the comments that are coming in at the moment. So we should be able to release this building block very soon at this point. As you can see, there are a lot of opportunities using this specification, very flexible building block. And yeah, it's one step closer to the cross-domain interoperability we all dream to have soon. And with this, I've reached the end of my presentation. So if you got any questions, feel free to ask me now or in the next break. I will be here until the evening. Thank you very much.
Thank you. Thank you, Christopher. Any quick questions now?